Welcome to the deep dive. Thanks everyone for sending in sources. We got some really interesting material this time, specifically a big meta-analysis looking at math interventions.
Yeah, for students who, find math challenging.
Exactly. So our mission today is basically to unpack this research, pull out the most important insights about, well, what actually makes these interventions work for those students.
Right. The main source you flagged is a meta-analysis of mathematics interventions, examining the impacts of intervention characteristics. It just came out in Educational Psychology Review 2024.
And it's pretty substantial, isn't it?
Oh, absolutely. It synthesizes findings from, I think, 223 different reports.
Which covered 286 separate studies and the number of students involved. It's around 56,477 participants.
Yeah, that's a huge pool of data. Really gives the findings some weight.
Definitely. So what were they trying to get at with all that information? What was the specific focus?
Well, what makes this one stand out, I think, is that it wasn't just asking if interventions work, sort of a yes-no question.
Right, more nuanced than that.
Much more. It was really digging into the characteristics, why some might work better than others. They looked at a whole range of things.
Like what?
Okay, so on one side, the intervention itself. Things like what grade level? Was it small group or one-on-one?
Uh-huh.
What specific math topic was being taught? Fractions, algebra, basic facts, and also the dosage.
Dosage meaning how much intervention they got, like
No.
time.
Exactly. How frequent, how long were the sessions, that kind of thing.
Okay, that makes sense. Already feels more useful than just did it work.
Right. And they didn't stop there. They also looked at the studies themselves.
How so?
Well, things like the research design. Was it a randomized controlled trial
Mm-hmm.
or something else? How well was the intervention actually implemented?
Ah, fidelity. You hear that term a lot.
Precisely. Did the teachers, stick to the plan, use the materials correctly? Because a great plan poorly executed,
Yeah,
well, it won't work.
of course. What else about the studies?
They also factored in the year of the study, how student progress was actually measured, which is a big one, and the overall quality of the research itself.
Okay, so lots of potential factors influencing the results they were seeing.
Definitely. All these things could potentially moderate how effective an intervention looks on paper.
So our goal here is to cut through some of that complexity and give you, the listener, a clearer picture of what seems to make a difference in helping students who struggle with math. What are the big takeaways?
Well, I think the first, maybe most fundamental point is just how much variability there is.
Variability and effectiveness.
Exactly. The meta-analysis found really significant differences in how well various math interventions worked. It's not like they're all equally good.
Okay, that probably rings true for anyone who's worked in schools. Some things just seem to land better than others, right?
Absolutely. It underlines that the specific details of the intervention really, really matter.
Yeah.
It's not just about doing something, but what you're doing.
So it pushes us to look closer at those details. Where did they find the most impact?
Well, that leads to one of the most interesting findings, I think. It's about the impact of the specific mathematical content being targeted.
Okay. Tell me more. What content areas stood out?
So the analysis showed that the specific math topic really did influence the overall effectiveness. And one area showed a particularly strong positive impact:
Which was?
fractions.
Fractions. Really? That's fascinating. You always hear that fractions are such a major sticking point for so many kids.
That seems to be exactly what the data is showing here. Interventions specifically designed to help students understand fractions. They had a more pronounced positive effect compared to others.
So dedicating intervention time specifically to fractions seems to yield particularly good results for students with math difficulties.
That's the clear message from this analysis. It suggests that building a really solid foundation in fractions could be like a key leverage point.
Why do you think that is? What makes fractions so foundational?
Well, it's often seen as a major conceptual shift, isn't it? Moving from whole numbers, which are relatively concrete, to thinking about parts of a whole, ratios, relationships between numbers.
Right, it's a different way of thinking numerically.
Exactly. It requires a different kind of number sense. And if that doesn't develop properly, it can really block progress later on. Think about decimals, percentages, algebra.
It all connects back. So if you don't get fractions, those later topics become much harder, maybe even impossible to truly grasp.
That seems very plausible. It acts almost like a gateway concept. So targeted, effective help with fractions could unlock a lot of subsequent learning.
That's a really powerful insight for designing interventions. Focus on the fractions. Okay, what else did this big review uncover?
Well, moving beyond the interventions themselves, The analysis also kind of shone a light on some challenges within the research field itself.
Oh, like what kind of challenges?
Specifically, the researchers pointed out what they call significant heterogeneity.
Heterogeneity,
Hmm.
meaning lots of variety.
Yeah, lots of variety in how student learning or proficiency was actually measured across those 286 studies.
Ah, okay. So different studies were using different tests, or maybe teacher-made assessments versus standardized ones.
Precisely. Some might use a broad standardized math test. Others might use a test specifically designed for the intervention content, maybe even curriculum-based measures.
And that makes it hard to compare results directly, I imagine.
It really does. If study A uses test X and study B uses test Y, and they focus on slightly different skills or are scored differently, comparing their effect sizes becomes, well, complicated.
Right. You're not quite comparing apples to apples anymore.
Exactly. It adds noise to the analysis when you're trying to synthesize everything.
So that's one challenge, the measurement issue. Was there anything else on the research methods side?
Yes, related to that, they also noted the variety in the actual research designs used.
Okay, so not just what they measured, but how they structured the study itself.
Right. You had some studies using randomized controlled trials, or RCTs, which are often seen as the gold standard for establishing cause and effect because of the random assignment.
Uh-huh. Control groups and all that.
Yes. But then other studies use different approaches, like quasi-experimental designs, maybe without that random assignment.
Which might have different strengths and weaknesses and maybe different levels of certainty about the findings.
Exactly. Each design has its place, but when you pool them all together in a meta-analysis, that variation in design rigor adds another layer of complexity.
So, interpreting the overall average effect has to be done carefully, knowing that it's based on studies with potentially quite different methodologies.
Precisely. It just highlights that educational research is complex. There are so many variables in real classrooms, it's hard to control everything perfectly, and different studies make different choices about how to balance rigor and practicality.
Okay, that makes a lot of sense. So we have this picture. Interventions vary in effectiveness. Focusing on fractions seems particularly powerful, but the research itself has these complexities around measurement and design.
Yeah, that sums it up pretty well.
So let's bring it back to the practical side. What does all this mean for, say, teachers, principals, policymakers, people making decisions on the ground?
Well, I think there are some clear takeaways. That strong signal about content, especially fractions, is really important.
How so?
It strongly suggests that when people are designing or choosing interventions, they really need to think carefully about the specific math concepts being addressed.
So maybe prioritize interventions with a really strong, explicit focus on developing fractional understanding, especially for students identified as struggling.
That seems like a very evidence-based approach based on this analysis. Given how pronounced the positive impact was for fraction interventions, dedicating focused time and good resources there seems like a potentially high-yield strategy.
Right. Not just general math help, but targeted work on those pivotal concepts. Yeah.
Exactly. Build that foundation.
Okay. And what about the research challenges, the heterogeneity bit?
Well, that serves as a reminder, I think, for both researchers and practitioners. For researchers, it points to a need for, perhaps, more consistency in measurement and reporting, clearer descriptions of designs.
So future meta-analyses can draw even stronger conclusions.
Ideally, yes. And for practitioners, it's maybe a caution against assuming any intervention labeled research-based will automatically work wonders in their specific context.
Right. Context matters. Implementation matters.
And the specific focus of the intervention matters. It reinforces the need for ongoing monitoring and evaluation within schools, too, to see what's actually working for their students.
So it's not just about picking something off a list, but really understanding its components, like the content focus, and then seeing how it plays out.
Absolutely. Informed decision-making combined with local evaluation.
Okay. So let's try and summarize the key points for everyone listening. We dove into this big meta-analysis.
Right. Hundreds of studies, tens of thousands of students.
And found that, number one, not all math interventions are created equal effectiveness, varies quite a bit.
Yep. Significant variability.
Number two, a really standout finding was the impact of content focus, with interventions targeting fractions showing a particularly strong positive effect for students with math difficulties.
That was a key takeaway for sure.
And third, the research landscape itself is complex. There's a lot of variety in how studies measure success and how they're designed, which makes synthesizing the evidence a bit tricky.
It adds nuance, definitely. It calls for continued rigorous work in the field.
So the variability tells us details matter, and the fraction finding gives us a specific detail that seems to matter a lot.
And a very practical insight, I think.
Which leads us perfectly into a final thought for you to chew on, given this really significant impact we're seeing with fraction interventions.
Well,
What are the deep underlying reasons that understanding fractions is just so critical for students, especially those who struggle with math? And maybe thinking beyond just interventions, how could a better appreciation of why fractions are so pivotal actually shape how we teach math more broadly right from the start for all students?
Hmm, that's a great question. Thinking about the core conceptual shifts involved.
Definitely something to mull over. Thanks for taking this deep dive with us today.